This lecture is for lipids for Exercise Science 219. So the first thing is that lipids can be categorized by three different things: fats, oils, and cholesterol. Now the difference between fats and oils is very simple. Fats are the solid form and oils are the liquid form. And they all have one major property in common. They are insoluble in water. Now, there are many sources of dietary fats. You have animal sources. We've already talked about how in animal sources of protein, there tends to be more saturated fat. In plant sources, a lot of times we see are more what's considered healthy fats. And then sometimes there's hidden dietary fat. So we know things that are fried, cooked in grease, are likely have fat in it. However, a lot of things like salad dressing, ketchup, a lot of our products, our processed food products, especially those that are considered to be more low calorie or gluten-free especially, have more fat content in them in order to create more flavor. However, there are many benefits to lipids and fats. And like I've said a lot in class, that I think all foods are good and all foods have a place. There's no reason we shouldn't take in fats in the right ways. They provide texture, flavor, and aroma to foods. A lot of times when you cook a product in the house, for example, steak, you know how steak smells as it starts to caramelize and cook in a pan or on the grill? Well, the actual smell that's coming off of that steak is related to the fat that is cooking inside the product. So you have that wonderful aroma because of the fat molecules. Now, phospholipids and cholesterol are in our cell membranes and are the starting materials for many other molecules. One important thing that we're going to talk about later with vitamins is that fat is critical in our body because we have to have it in order to utilize those fat-soluble vitamins. They're a lightweight, long-term storage of energy. So remember, they're not preferable for energy, but if necessary, our body can break down fats for energy. And also, fat provides insulation, cushion, and lubrication for our body. So the first thing we're going to talk about is fatty acids. And one thing that we're going to try to do in this lecture and when we come back to class is create a chart similar to your carbohydrate chart that breaks down the different type of fatty acids. And that'll help make it a little bit more clear. So the first thing we think about when we think about classifying fatty acids are how they're attached to that glycerol backbone. So is it one fatty acid on a glycerol backbone? Is it two fatty acids, or most commonly found, three fatty acids? Remember, it looks like a big E. And then we talk about the level of saturation. Now, what is saturation? It literally means it's saturated with hydrogens. So remember the honk 1, 2, 3, 4. Carbon is happy when it's completely surrounded by 4 other molecules, or when it has 4 electrons in its outer shell. With carbon and fatty acids, when they're completely full and happy with hydrogens, that is considered saturated. And then you have cis versus trans. So this is a triglyceride. Like I said, it looks like a big E. You have your glycerol backbone, and you have the fatty acids. Absolutely do not worry about drawing the carbons and the hydrogens here, but definitely do need to draw that E and identify that there's 3 fatty acids in that glycerol backbone. So be prepared to identify and draw and diagram a triglyceride. Now, it is important to know, I'd like to back up and say that 95% of the fatty acids found in our body are in triglyceride form. So that is by far the most common type of lipid. Then we have saturated and unsaturated fat. So like I was saying, that saturation means it's saturated by hydrogens. So if you look at that molecule on the top, you can see every single carbon has at least 2 hydrogens attached. And then the ones on the end also have hydrogens. Now, when we have an unsaturated fat, your carbons are not saturated with hydrogens. And what you see where they don't have those double hydrogens, right over here to the right, you see a double bond in place of it. So that's what you're going to look for when you try to identify the differences between the two. Are there hydrogens all the way around every single carbon? And is there a double bond? Now, let me talk a little bit about saturated fats. Saturated fats a lot of times are used in food industry products because of the fact that they are more shelf stable, so they don't go rancid as quickly. So they're much preferred. So we see saturated fat added to food products. However, it is considered a more unhealthy fat. See that double bond there? And one thing that happens whenever we add a double bond is that you end up having the fatty acid sort of kink. So that double bond causes a kink in it sometimes. And we're going to talk about what that kink actually is called. But sometimes if you think about unsaturated fatty acids, you'll think of a kink in it where the double bond is. A saturated is completely straight across. So remember we said that we could think about it as mono and tri and di and those types of things. Well, now noticing we're talking about unsaturated fatty acids, so we're talking about at least one double bond. When we talk about mono unsaturated fats, we're talking about one double bond. And I tend to call these MUFA, M-U-F-A, mono unsaturated fats. And then we have polyunsaturated fats, just indicating that there's more than one double bond. And I call those PUFAs. Now, this chart actually shows you some of the differences in saturated fat and unsaturated fat content in some of the oils and the fats that we typically use. What I would like to draw your attention to is at the bottom of the chart are those products with the most saturated fat, or that red bar. Coconut oil has far more saturated fat than butter. So a lot of times we think of butter and lard as being terrible things, and they're not great. There are better replacements for them. However, coconut oil, which is deemed a healthy product, has a ton of saturated fat in it, and very little of our MUFAs and PUFAs, which we typically think of as healthy fat items. Some of our healthiest fats, we see safflower oil, canola oils, and sunflower oils. Now, because those are not saturated with hydrogens, they tend to go rancid quickly, so you have to pay attention to them when you keep them in the pantry. Now, another category is cis and tran. Now, cis and tran are both unsaturated fatty acids. And cis is a type of unsaturated fatty acid. Here we have a MUFA, so a mono, where the other hydrogens are on the same side, like sisters. So look at the two carbons that are connected by a double bond, and then those hydrogens on each of them will be on the same side. What that actually causes is it causes an unweight in the molecule, and those kink. Now with a trans fat, it's the same thing. We have a double bond there. It's just our hydrogens are on opposite sides. And that creates more balance in the molecule weight-wise, and so it stays straight. And the way that actually looks is here. So your cis is kinked or bent, unsaturated fatty acid. This kind of just gives you a more realistic look of what these molecules actually look like when they kink. So we've already talked about trans fat. It is found in very small amounts naturally in dairy products. And we've talked about how it's actually great for the food industry because it was created by the food industry to mimic that process of hydrogenation, or adding hydrogens to saturate it to make it more shelf stable. And so now what you have is this decreased ability to become rancid on the shelf and increasing that shelf life. However, this is the most dangerous dietary fat. And remember, we're looking for that partially hydrogenated oils in the ingredients list. Just a reminder on that food label and what we're looking for there. Okay. Another type of unsaturated fatty acid that we're going to think about specifically are omega-3s and omega-6s. And we're actually going to have a guest speaker next week that's going to talk a little bit more in depth about these and why they're so beneficial for the body. I'm sure a lot of people have heard of these. These are omega fatty acids, and they get a lot of hype about being super heart healthy, right? And they are really critical to have. They're actually essential fatty acids, meaning that we have to eat them in our diet. Our body just can't make them. The real difference here, and I don't expect you guys to memorize this portion of it, the big difference here is we have a double bond for each, but when it's an omega-3, that double bond is at the third molecular standpoint, and at the sixth, the omega-6 is at the sixth carbon. So once again, similar to think about the carbohydrates and how glucose and fructose and galactose have the same chemical formula, this is very similar. Just the type of structure differing slightly creates a different compound. And I don't expect you to know these names either, but alpha-linolenic acid is omega-3 and linolenic acid is omega-6. Now, very similar in the types of food products. We're talking about salmon, we're talking about those heart-healthy seafoods, leafy greens, kidney beans, olive oil, nuts and seeds, a lot of those things, very similar with omega-6. We're talking about oils, healthy oils, but we're also talking about eggs and meat and dairy products. So definitely knowing the difference in what types of food products are high in omega-3 and high in omega-6 would be an important thing to know. Also important to know that they're essential fatty acids. Okay, and same definition we always get, essential fatty acids cannot be made in the body, so they're essential to eat. Non-essential can be made by the body. So just knowing that omega-3 and omega-6 are essentials. Now here's this chart I want you guys to recreate for me, okay? This kind of gives you a breakdown of the way that we think about fatty acids. So we have saturated and unsaturated being one of the top hierarchicals, and then under unsaturated we think about MUFAs and PUFAs, and omega-6s and omega-3s are actually considered PUFAs. You can't see the rest of the molecular compound, but there's more than one double bond there. And then thinking about the fact that cis is one category of unsaturated fats, and it is naturally occurring and it's kinked or bent, and trans is industrialized and it's straight. You do not have to add this to your chart, but these are examples of food products that are rich in these particular types of fats. I also do not expect that you be able to identify that olive oil and canola oil are MUFAs or those types of things. I would like you to know the omega-3s and omega-6s. I would like you to know that trans fat is processed foods and that saturated fats are typically animal fats. So this is a chart that you can make for yourself that I would highly recommend. You could do it on the back of your lipids chart if you want to, because I would expect that you guys know this. When thinking about our categories, our least healthy by far is that industrialized trans fat. And then we have saturated fats, those animal fats. Then we have omega-6s. The reason the omega-6s is there is because a lot of times we actually get enough of that in our diet normally as Americans, even with that westernized diet. Then you have MUFAs, and then you have omega-3s or PUFA omega-3s. Okay, so thinking a little bit about how fats are part of that, remember with nutrients, they have to promote growth and development and also regulate body processes. Well, one way they regulate body processes is acting as a major component of our cells and our cell membranes. And so a phospholipid is a fat that has a phosphate group attached to it. Here's that phosphate group highlighted there. Now, the reason that's important is because now when you have a phospholipid, you actually have a hydrophobic and a hydrophilic different sides of the structure. And so meaning that you have hydrophobic being kind of afraid of water and hydrophilic meaning attracted to water. It creates that lipid bilayer of all of our cells. That's really, really important. And so what it does is we see that hydrophobic hydrophilic, that exterior that's attracted to water, and then the insides being that hydrophobic. Okay, this is important for you to know. Another type of fat is cholesterol. What makes this a different type of lipid is we previously talked about how it's got that glycerol backbone and it's got fatty acids attached. A sterol is different because it is actually a complex ring structure. Similar components, but it's a complex ring structure. Be prepared to either draw that or define it. So when we talk about foods that are high in cholesterol, I think eggs have gotten a bad rap. So we have eggs on here, beef liver. The reason liver is a high component of cholesterol is because that's where cholesterol is synthesized. So if you're eating that organ where it's synthesized, you're going to get a high amount of cholesterol from it. Salmon, chicken breast, milk. One thing that's not on here that is also high in cholesterol is shrimp. Now, here's my disclaimer that eating cholesterol is not an issue unless you have an issue with cholesterol. So unless you are somebody that already has cardiovascular disease, has bad lipid levels, you don't normally have to worry about consuming too much cholesterol. But it's those people that already have existing issues that we kind of warn about taking in more than they need to. So cholesterol is an animal sterol. Remember, sterol is the ring structure. It's a non-essential nutrient, so it's made by the liver. We see it in the cell membranes of animal cells, and we also see that plant sterols, example margarine, can reduce human cholesterol. It's used to make vitamin D and steroid hormones such as cortisol, estrogen, and testosterone. And it's important to know that cholesterol is found in every cell of your body because it serves as a building block for hormones and vitamins. It's produced in your skin with exposure to sunlight. So really what happens is that vitamin D comes in, and that vitamin D is that precursor that gets converted over in the liver. It's a major component of nerves and brains, but it cannot be used for energy. It has no caloric value. Now, when we transport cholesterol in the blood, because fats are naturally hydrophobic, meaning they don't want to be in water, and blood is made of mostly water, we have to take fats around in our body with molecules that are attracted to water, that are okay with it. And the way that we do that is we use lipoprotein. So basically a protein package that transports lipids in our blood. That's all it is. Now, so LDLs and HDLs, I'm sure you guys have heard of these. These are cholesterol. So dietary fats such as cholesterol and triglycerides, which are things that we check and you'll see on blood values, they're packaged in these lipoprotein particles for transport through the blood. Kind of looks like this. Now, what is an LDL, a low-density lipoprotein? An LDL is what's considered the bad cholesterol. It delivers cholesterol to the cells. And the LDL particles actually bind to specific receptors on the cells that help cholesterol move from the blood into the cells to be utilized. Now, high-density lipoproteins, or HDLs, are considered the good cholesterol. The reason these are considered to be a good cholesterol is because what they actually do is they take cholesterol from the cells to the liver where it's converted to make bile. So it's actually decreasing the amount of cholesterol in your body. So you want plenty of these. So unfortunately, what tends to happen in people that have problems with their fats in their body is they have too many of that bad cholesterol, or LDLs, and not enough of the HDLs getting rid of it. So what do we tell people to do? We tell them to decrease their trans fat, their saturated fat, and cholesterol. Replace these with PUFAs and MUFAs, not carbohydrates. We see that happen a lot. Quit smoking, exercise, improve social relationships. So we kind of talked about this a little bit, but the reason LDL is important, or the reason HDL is important, is because it gets cholesterol out of your body, and LDLs transport cholesterol into your body cells, which is critical to have. So a lot of times we think about this in a ratio, like you want to have the right ratio. It's important that you have LDLs, but you don't want to have too much. And it's important that you have HDLs. You just don't want to have too little. So you need to know we want low LDLs and high HDLs. Now, we've already talked about bile, and bile is stored in the gallbladder before entering the small intestines. Bile emulsifies dietary fat. We talked about this, breaks up those larger particles and makes it more accessible to the lipases. Dietary fiber and cholesterol are actually used to make bile. So here are target levels. I do not expect you to memorize these. I would like you to know to keep your LDLs low and your HDLs high enough. So what is heart disease? This is very related to dietary fats, because when we talk about dietary fat consumption and what fats are, it's very related to what's going on in the body with heart disease and cardiovascular disease. So heart disease specifically is a collection of diseases that describes insufficient blood supply to parts of the heart. And normally it's due to narrowing of those arteries. A lot of times you've got plaque deposits in there related to cholesterol. Also, atherosclerosis is the hardening of those arteries due to the buildup of plaque. Now, the difference here with cardiovascular disease, now you have a collection of diseases that not just talk about heart relation, but now we're talking about in the brain, in the organs and other tissues. And so you have buildup of plaque in all those other arteries as well. And we see this very connected to insulin resistance, so that type 2 diabetes. Causes could be genetic or lifestyle, but very similar to diabetes. It's a combination of both typically. With risk factors, we see poor diet, smoking, type 2 diabetes, high blood pressure, obesity, not being physically active. We see problems with the blood lipids, and sometimes we see differences in family history. Age, so greater age increases your risk. Gender, a lot of times we see males being a little bit more prevalent with this. Race, once again, this is an African American issue sometimes that we see a little bit more prevalent in that population, also Native American. This just gives you a good visual of the atherosclerosis, about that plaque buildup and some of the problems that we can see happen when you have that plaque buildup. Sometimes you can see a blood clot there, and then all of a sudden that plaque will rupture off and block an artery, and that's where we see heart attack, stroke, those types of things. Now, the difference in a heart attack and stroke is it's literally the same thing happening. It's that plaque breaking off from the blood vessel walls and stimulating a clot formation to block the blood flow. So there's a lack of blood flow. In a heart attack, it's just happening in the heart. In the brain, it's called a stroke or a cerebral vascular accident, the CVA. So what do we tell people that are at risk for heart disease? What do we tell them to do? Well, we tell them to increase plant foods and limit their animal fats. Why? Because we're talking about saturated fat in those animal fat food items sometimes, which can be a little bit less healthy. One thing that they can do is they can use plant sterols as a fat source. So here we have an example of margarine, or actually it says butter and canola oil, but it's supposed to be margarine. Margarine is an example of a plant sterol. Margarine is a great product for somebody that is high risk for heart disease, because those plant sterols can actually sometimes try to remove some of that blood cholesterol, and you're not talking about animal fat, so you're not increasing your risk. We want to tell them to take in more PUFAs and MUFAs and limit maybe some of those refined carbohydrates. Okay, so DASH diet. This is one thing you need to know. And a lot of times we see this as a DASH diet pyramid. If I don't have that pulled up, I will make sure to email it out to everybody, just so everybody is aware of what that looks like. This is a very basic, similar diet to my plate, where we're talking about whole grain products. We're talking about lean protein, eating fish, changing up your protein source with nuts and seeds and beans sometimes, vegetable oils. We're talking about fruits, vegetables, fat-free or low-fat dairy products. And the one thing I would really say that makes this quite different is we're also talking about limiting sodium. We definitely want to think about sodium, because sodium can increase blood pressure. So just remember about its physiological fuel value, okay, 9 kcal per gram. Remember it's 10 to 30% on that macronutrient breakdown. And the one thing I'd like you to take away from this is that we talk about taking in less than 7% of your total calories as saturated fat items. So making sure you're getting in some of those PUFAs and MUFAs. When we talk about some of the fat labels, one thing we think about is the nutrient claims. Low fat means it has 3 grams of fat or less per serving. Reduced fat must have at least 25% less fat than regular versions of these foods, and fat-free is less than 0.5 grams of fat per serving. So there can still be some fat in there, similar to trans fat. It's a very small amount, but there can be fat in there even with a fat-free product. Here are some key points to take away. Remember that 9 kcals per gram, not all fats are created equal, so make sure you know the healthy to unhealthy. And triglycerides make up 98% of our dietary fat intake and a majority of our body's energy stores. Lipoproteins, a name that describes the molecules your body uses to transport fat. HDLs is the healthy cholesterol, the higher the better. LDLs are the unhealthy cholesterol, the lower the better. And remembering we're talking about lifestyle changes again. So diet, exercise, and weight loss are the best ways to lower some of those high fat values in your blood. And that is the end of this lecture.